Honors Algebra 2, this is a video just about the unit circle. So it's kind of 13.2, 13.3-ish in the textbook, but we're just going to look at the unit circle. So here's a unit circle. Really what we're talking about is just a circle where the center is at the, and then it has a radius of 1. That's why it's called the unit circle. So its radius is unit 1. Here's the equation from a unit circle. We won't use that much for this chapter. We use it more in conic sections. You should have seen that in geometry a little bit as well. So we're looking at a circle with radius 1 and center at 0, 0. So if we look at the circle, we've already talked about how to split the circle into these special right triangle angles. So the 30, 60, 90, the 45, 45, 90. Then we have our right angles, our 90, 180, 270, 360. These are the angles that we will look at in the unit circle. So then we get to this unit circle. So really what we're doing here is we're looking at an angle here of, for this example, this one is 30 degrees. It creates a right triangle. If we take this radius from the center to the circle, that radius has a length of 1. If we take the point where that radius intersects with the circle and drop a vertical line to the x-axis, we create a right angle right there. So here is a right triangle. Now, this leg of the right triangle is not a length of 1 because it doesn't go to the circle. It's less than 1. But the hypotenuse of this right triangle is 1. And so if we use our 30, 60, 90 knowledge, we should be able to build the measurements of this right triangle. And so if we think about 30, 60, 90, if our hypotenuse is 1, our short leg here has to be 1/2. Our long leg has to be our short leg 1/2 times √3. So if we multiply that, you get √3 over 2. So that's going to be the long leg. So now we can make this a point. We can actually find the value of that point, or the coordinates of that point, because it has an x value and a y value. So the x value is the long leg's length, is the x value, the square root of 3 over 2. And then the y value is 1/2. So that's how you can find the point, for the coordinate for this point. Now, why is that important? Well, let's look at our trig functions. If we look at the sine of 30, the sine of 30 degrees, what is that? Well, for this, it's the opposite 1/2 over the hypotenuse 1. So 1/2 over 1 is 1/2. Since our hypotenuse here is 1, it's just going to be what our numerator's value is, which is 1/2. That 1/2 is the y value here, or which we can call the sine value. So that y value actually is the sine at this angle, 30 degrees. If we want to find the cosine of 30 degrees, cosine of 30 degrees is the adjacent, so it's going to be square root of 3 over 2 over the hypotenuse 1. So it's going to be square root of 3 over 2 over 1, which is just √3 over 2. So that is just the x value, which is just cosine. So the x value is the cosine of this angle of 30 degrees. And that's going to be true with all of these points on the unit circle, is that these points tells us the cosine and the sine at the given angle. That's why these points are important. And so if we go around this unit circle, we have this angle here 45, then we have this angle 60, then we have 90, and it keeps going all the way around. Knowing that the x value of the unit circle is cosine, the y value is sine. And how would you find tangent for this example? We can use our knowledge that tangent of theta is actually equal to the opposite over adjacent, which would be 1/2 over square root of 3 over 2. We realize 1/2 is the same thing as sine. Square root of 3 over 2 is the same thing as cosine. tangent is equivalent to sine over cosine. Cosine of those angles theta, which ends up being 1/2 divided by square root of 3 over 2. And a lot of you remember this from last chapter, simplifying that. That's going to be 1/2 times the reciprocal. So that's 2 over root 3, which we get those reduce out. So you get 1 over root 3, which I rationalize that as root 3 over 3. And so when we deal with the unit circle, we're really dealing with these three right triangles within the unit circle. And so you think about how if we have 1 for 36 feet, y was 1/2, and then x was the square root of 3 over 2. That's what we use our knowledge from our special right triangles. For a 60-degree angle here, it's flipped. The x is the 1/2, that's a short leg. Y is the square root of 3 over 2. And these are just straight from our special right triangles. We have 45, 45, 90. If this is 1, if these are special right triangles to solve, this becomes a square root of 2 over 2. And this is identical, square root of 2 over 2, because we have 45, 45, 90. So here's what it will look like with a unit circle, given the 30, 45, and 60 degrees. Notice that when we reach the 90 degrees, our x value is 0. So we have an x value of 0, but we go up a radius of 1, so we have the point 0, 1. We go left at 180, it's negative 1, 0. Down it's 0, negative 1, and right it's 1, 0. These should be some of the easiest points, but there are ones a lot of students have a careless mistake. They flip-flop the numbers by accident. So this is really the picture we did from a previous lesson. And notice how we don't just have the angles, we also have the radian measure. You have to be able to create this circle with both the degrees and the radians. Then our next step is to actually write the point for all of these, write the coordinate for all of these points on the unit circle. And all of these are made by these special right triangles. And they're going to be the same ratio, so you have to see these triangles within the circle. So this is the overall definition of sine and cosine tangent, the 6 trigonometric functions given any radius. But for our case here, the unit circle, we're letting our radius here be 1. Now this is only a special case if r is 1. For the unit circle, this is going to equal 1 squared, which is 1. And so what we're doing with the unit circle is this case where the sine is y, cosine of x, tangent sine over cosine. And then cosecant, secant, and cotangent are just the reciprocals. Notice how we have some restriction on our domain because of our fraction. We have y and x in the denominator at some points. So how does this help us out? If I want to know the cosine of 90, cosine, again, cosine is the first value, the x value is cosine, so I know it's 0. I just know it from the unit circle. Sine of 45, so I find 45 degrees. It goes cosine, sine, so think CS, it's alphabetical, so the second one sine, which would be square root of 2 over 2. Tangent of 30, so tangent of 30 here, it's the one we just did actually. To find that, we have to do the sine over cosine, y over x. And so we already showed that in the previous page. It was square root of 3 over 3. Cosecant at 180. So cosecant is the reciprocal of sine. So let's first find the sine at 180. The sine at 180 is y, is 1. It's the y value of that point, which is 1. So this is a fraction, is 1 over 1. So the reciprocal would be 1. 1 over 1 still. Cotangent is the reciprocal of tangent, so let's find the tangent of negative 315. Now wait a minute here. Where in the world is negative 315? So negative 315 is going the opposite direction, 315 degrees. So we have 45 degrees left over before we hit 360. So we're at the same spot as 45. This is the same thing as the tangent of 45 degrees. The tangent of 45 is found by doing the sine over cosine. Those are the same measures, so it's just going to be 1. The cotangent is the reciprocal. Again, 1 over 1. The reciprocal of that is still 1. Now, secant, negative 90 degrees, different quadrant. Negative 90 degrees is down here. Is the same thing as 270. Secant is the reciprocal of cosine. Cosine of negative 90 then. Cosine is the zero value, CS. So it's cosine and sine, x and y. So cosine negative 90 is 0 degrees. 0 over 1 if you want to write as a fraction. So the reciprocal of that is 1 over 0, which is undefined. So here is a unit circle kind of started for us. We have the circle, we have all of the angles already done. Now the points are already filled out here for that first quadrant. We're going to look at how to find the points on the other quadrants quickly. There are really a mirror image here because our reflections. If I draw a horizontal line here, I'm going to have those two match. And that happens, the 30 and the 150 match. Draw another line here. These are reflections and more reflections. So if I want to find these values in the second quadrant, I can do reflection over the y-axis. So I can flip it over the y-axis here, because these measures on both sides of the y are equivalent. So reflection. So the y value does not change, but the x value just becomes negative, because we're going from a positive x value over here to a negative x value. So all of these values right here are the same as the first quadrant, except they're going to have negative x values. Quadrant here we already talked about is negative 1, 0, 270, we talked about that, that's 0, negative 1. Now how to get the bottom values right here. These are just reflections from the top. I take this value and I reflect it down, straight down vertically. So I take this point and I move it down here, I reflect it down. What's going to happen? The x value stays the same, I'm just going straight down with that point. But the y value is going from positive 1/2, flipping it over the x-axis, becomes a negative 1/2. So these are just reflections of the points above the x-axis. What's a reflection over the x-axis? These again, the x values will stay the same, the y values become opposite of these up here. So these are a bunch of reflections really. Once you get the first quadrant, you know all the other points. It's just a matter of reflecting and placing them in the proper spot. So now I not only know the sine of 30 and 45 and 60, now I know the trig functions of all of these angles really quickly. So if I want to know what is the sine of 315 degrees, it's cosine sine. This is our sine value. It's negative root 2 over 2. And so we can quickly find these values.